Okay, let's look at this problem. We have DE, which is a string which is inextensible. You have a force P and a Q acting vertically downward on these two masses. You have ABC, which is CB is a bar, AC is a bar, and these are sliding along them. Okay, that's the question. Now we need to find out, as pointed out here, the balls D and E can slide freely along this. Using this principle, we need to find out the theta for equilibrium. Okay, so now let's understand this. There is this particular inextensible string. Let's call this as L. This length does not change at all. What changes is this CD and CE. Okay, so let's write down the relationship first. So the relationship between L, CD and CE are CD is equal to L cos theta and CE equals L sin theta. What we have done basically is we have expressed these two changing variables in terms of theta and the unchanged L. Now it's easy. We just need to find out the variation of CD. That is nothing but minus L sin theta delta theta, and delta CE is L cos theta delta theta. Right? Now mind you, there is one force acting like this, another force acting like this. The component of P, this is 60 degrees, because this is 60 degrees, this is 30 degrees. We can take the component of this to be like this and like this. Similarly for this component, like this and like this. This component is inactive for virtual work. This component is inactive for virtual work. So only this component and this component of the two forces will be taking part. So now we can write for virtual work principle, P, you have cos 60 degrees here. This is the force times delta CD plus Q in this direction, which is Q cos 30 degrees, which is the force, times delta CE is equal to 0. This completes the entire thing. Now all we need to find out is what is the relationship between P, Q and theta. Mind you, this will be in terms of delta theta, this will be in terms of delta theta and theta. Right? And therefore it's possible to find out the relationship between these two. Okay. Now in this particular case, theta happens to be, tan theta happens to be root of 3 Q by P. Please verify if this is fine. You can also write this as theta equals tan inverse of root 3 Q by P. Alright. I hope you got this. This is problem number 1 in tutorial 5 AM1100 January to May 2010. Thank you.